So we got kind of three pieces of vocabulary here that we want to make sure we are knowing about, and then we'll get into the actual types of transformations that are out there. Okay, first thing is a pre-image. When I say the word pre-image is that original figure that was there. So on here, a pre-image is it is the original figure before a transformation occurs. So when I hear the word transformation, myself, I go right back to like Optimus Prime and Transformers. That's where I grew up from. So I got this original figure. Okay, the transformation occurs, and we call that pre-image. That first one is before anything has happened to it. Then something happens. What we have is three types of transformations we're going to look at. There's a fourth one we'll talk more about second semester. But when a transformation occurs, we drop off the pre, and we call it just the image. What's that?
I said we was doing that one on that.
Yeah. Oh, okay. So then the image is the resulting figure after a transformation. And as we'll see over the course of the next few weeks, all right, we'll see more than one transformation happening at a time. That gets a special name when that happens. But we have a pre-image we start off with, something happens to it, and then we drop the pre, and then we have an image. Now, we are going to look at, over the course of these next few weeks, three types of transformations. And these three types of transformations are what we call an isometry. Not every transformation is an isometry. So let's talk about what is an isometry and what's not. And we'll talk about what's not later on in the second semester. All right, so let's take a look here. What is an isometry? An isometry is, let's see, make sure I phrase this right, where the pre-image and image are congruent after a transformation. Okay. So we have different types of transformations out there. We have four. Three we'll focus on right now, and then the fourth one we'll talk about again later on. With an isometry, when a transformation occurs, if it's not the same shape and same size, that's congruence. Congruence is, let's put this off to the side here, okay? Let's see. So congruence is not that, a little bit too fat. Stress again, zoom it down. So, same shape and same size. Again, that's a congruence. If that's not happening, then it's not considered to be an isometry. So what are the three isometries we're going to look at here today? I've got them on the paper. We have three types, okay? And I'm going to scale this out for a second so I can not do that. Try this again. All right, zoom this out a bit so I can talk about things with you. So transformations, we've got four of them. Okay, we can either go the route to be an isometry, and when we do that, we have three varieties. Okay, one variety is what we're about to do first off, is a translation. Okay, a translation. And what we mean by a translation is, that's a slide. Kind of the layman's version of that is what we call a slide. So you're taking that pre-image and you're sliding it left, right, up, or down. That's that's a type of isometry, because when you slide it, all right, you're not changing any shape, you're not changing any size, you're just literally moving it left, right, up, and down. Another one we're gonna look at here in just a minute is a reflection. And kind of the layman's version of reflection, that's a flip.
Feels like they mirror thing.
What's that?
These are mirror thing.
That's what you had heard?
Yeah.
Yeah, same thing. So reflection is the other type of isometry. So you're just flipping it over, some type of what we say is line of reflection. And then the third one we're gonna look at here today as well is the rotation. And rotation you can hear is just as like a term, okay? Come on, should erase, there we go. As I was saying, a rotation there. And with that rotation, what did I just say? It's a turn. Okay? So those are the three types of isometries that we're going to run into. The fourth thing that's out there that we're going to get into more second semester, and if you're maybe in type of any engineering classes right now, you might be doing those already. The non-isometry. Okay? The non-isometry. That is what we say is a dilation. Okay? And what I was saying a second ago is maybe if you're engineering right now, architecture class, anything like that, first thing I go to is blueprints. Okay? Blueprints, that's like a dilation. It takes the real world, puts it onto something that's easy to carry around. Okay? So maps and blueprints. So dilations, we'll talk about those a little bit maybe over the next week or so, but more second semester. Okay? But what we're going to focus things on is, bless you, these three things right here are isometries. They're pretty straightforward, so let's go ahead and talk about those, and let's jump into that first one that you see right there. So when we do these, we can look at this in a couple different ways in terms of talking about them, of how to transform them. And in one way we can do is just literally using it in words. Okay, we get our words, we get notation styles, we get different types of notation styles that we're going to see. But let's just start off kind of basic there. Take that first one, it's a quadrilateral. Transform it based off of what's being described there. Okay, if you haven't done so yet, again, go ahead and transform that. So I'm going to do that as well. Okay, so we want to go 5 units left and 2 units down. Basically, as long as you can count and you know your directions, it's pretty impossible to screw up a translation. It's not impossible, but it is kind of hard to do. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Oops, forgot to do up, didn't I? Or down 2. Come on, there it goes. So then down 2, 1, 2. Let's try this again. Down 2. Down 1. I can't do anything today. 1, 2, 3, 4, 5. 1, 2. Now after you transform things, 1, 2, 3, 4, 5, down 2. Always take a step back and just make sure of whatever shape you just drew looks the same as what we just had. The pre-image and the image better be congruent because this is an isometry. You're just sliding this left, right, up, or down. Now, as we work through here, we want to make sure we also talk about the notation, some of your notation. So when I look at this, we want to make sure we can distinguish between which one was there first, which one was there second, the pre-image versus the image. So we need to put some notation on our new picture here that tells me this is what we call now as the image. So what we use, anybody remember what we use there? Or if we would counter that? Yeah, we use the apostrophe. And how that's read then in math is prime. So we call this W prime, V prime, Y prime, X prime. All right, so yeah, when we do a transformation, we get that image. We use those primes to tell us that this is the resulting image. If it doesn't have a prime on there, as this right here doesn't, that then tells you that was the pre-image. Just know those two things, you'll be good to go. If you haven't done so yet, take the third one there and then do its transformation. Don't forget about our rotation style. I will take off on small things like that, like I've done throughout the school year. You should be able to distinguish, if I'm looking at this not knowing anything here of which one's the pre-image and which one's the image. Again, that notation tells me which one is what, so make sure you are doing that. Okay. Take a second to do it out if you haven't done so yet. You're gonna take that thing and slide it down. How many units? Four. No, not down. We're going forward to the right. As we'll see over the course of this day here too, sometimes the resulting image lands on top of where the pre-image is. It gets a little messy. So that's again where those notations, those primes, labeling those points come into style. All right. So, all right. 1, 2, 3, 4. 1, 2, 3, 4. Again, once you make that 1, 2, 3, 4, always take a step back and make sure that the resulting image looks congruent to the original. If you find that, say, Z, you accidentally copied it and you went down one, bless you. This is going to be more stretch out, bless you again. More stretch out, that's not no longer an isometry, they always should be. Okay? So one of the first things you usually learn about is a transformation is in words. Not always have to be in words, so let's go to the next part where hopefully you've seen this notation style. If you haven't, no big deal. Don't overthink this, okay? So when we look at this translation style here on number 4 with the notation, what this is read as, take the original, take the pre-image coordinates, and do this transformation here to it. So how would you translate this into words? When I see x plus 6 and y plus 1, what does that mean in words? I don't.
Right 6 up 1.
Yeah, don't overthink it. If it said minus 6, x minus 6, what would we do instead?
Left.
Yeah, if we said y minus 1, we would go
Down.
Don't overthink it. It's exactly what Meadow said there. Take that pre-image and go, what did we just say? Right 6 and up 1. Don't overthink that, okay? Now you can run through that now pretty quickly. Take a point, just follow it along. 1, 2, 3, 4, 5, 6, up 1. What is that? U. And did I put the primes on the previous one? Yep, I did. Always make sure you're putting those primes here. 1, 2, 3, 4, 5, 6. Oops, forgot to go up 1. And make sure you do the whole thing. It's easy to maybe forget to do one of the other parts of it. And 1, 2, 3, 4, 5, 6, up 1. 2 prime. And there we go. On that next one, well, that's kind of crappy, so let's go ahead and let's just skip over it because it's the exact same thing, right? 5 up 4. If we said again, if it was a minus 4, we'd go down 4. I need to fix those out. Okay. All right, with reflections. Doesn't really right now get any more crazier than that, kind of reviewing things on in words, that notation style, and then we'll introduce you to another type of notation style. It's one of these things too of maybe what textbook you're stuck with. Depending on what textbook you're stuck with, sometimes they keep it right here. Sometimes they'll kind of update that notation style. It just kind of depends, and we'll show you a little bit of everything over the course of this, over the course of these next few weeks. All right, so let's flip it. Took away your graph, so go find me the coordinates now. When I give you that translation rule, what are the new coordinates going to look like with that translation rule? So what I'm looking for from you guys, we got a triangle here. And on that triangle, to get x prime, just as Meadow said a second ago, on this one, you can basically plug in the, not basically, you do plug in the coordinates and you just do the operations that are there. So for -4, we start off with the x of -4, plug it in. What's -4 plus 3 going to take you now to? -1, right? So that did what? A right 3. And then for the y coordinate, we start off at 0, and then what are we doing with it? minus 5. So 0 minus 5 is going to put us at, yep, negative 5. So you went negative 4, 0. You went what? Right 3, down 5. Just keep plugging those points and getting those new coordinates. That's pretty straightforward. W prime. Okay, W prime. You start off at negative 5. Negative 5 plus 3 takes me 2. And 4 minus 5 takes me 2. And then V prime. Yeah, negative 2 starts off, plus 3. And then 1 starts off, minus 5. It doesn't really right now get any crazier than that. Okay? We can do it with a triangle, we can do it with a quadrilateral, we can do it with a pentagon, and so on. Alright, we usually fall right around the triangles and quadrilaterals. Okay? So, I think you got the idea. Let's take a look at that real quick on number 7 as I'm looking at one. For I prime. So we're taking the pre-image coordinates x, y, and doing a translation rule of x comma y minus 1. So if I start off at 1 comma 0, where's 1 comma 0 going to now be? 1 negative 1. Did you move anything on the x's? No, because they told you not to. Okay, if they told you to move, they would have a plus 5 and minus 6 there. But because it's just x, then you keep that locked in that place, and all you're doing is taking everything and you're going down 1 unit. So what do we just say? 1 negative 1, and then h prime is where? 1 1, and then g prime is 3 2, and then f prime is 4 2. Okay, so if the translation rule is just still staying x, you're not moving on the x value. Okay. All right, let's reverse things. This is where sometimes the students don't really pay attention very closely to the notation style. I want you to write a rule that, whoops, let's try this again. I want you to write a rule that is what we just been doing here. Okay, so right here is what I'm looking for, is some type of answer that looks like that, based off of what just got described in question 8. So follow the point. Okay, pick a point and follow it. U to U prime. How did U become U prime? What rule had to happen with that? And then once you create that rule, just check to make sure it works for the other points that are up there. Okay, because whatever happens to one, everything else doesn't. It's true for a translation, it'll be true for a reflection, and then it'll be true for a rotation. So, translation rule I'm looking for today from you guys is how we write this up. Okay, so that pre-image coordinate x, y, how's that going to get transformed? So we start off at negative 5, then we were at 0. How does that happen? Add 5, right? So we had to add 5. And then for the y value, y coordinate, we're at negative 3, then we're at 1. Plus 4, right? So y plus 4. Once you think you have your rule correct, just do a quick check to make sure you didn't do anything silly. So now, if I plugged in v, do I get these coordinates for v prime? Negative 5 plus 5 is 0. 1 plus 4 is 5. That checks out. If you checked out for 1, you should be fine for all the other ones. Okay. Real quick on number 9, if you haven't done so yet, take number 9, create me that translation rule. Okay. Pick a point, follow it, and for the x value, what are we doing there?
Plus 6.
Caleb's saying x plus 6, negative 3 to 3. The only way to do that is a plus 6, yep. And what's happening on the y coordinate?
Minus 3.
It starts at 0, then you're at negative 3, and the only way to go from 0 to negative 3 is, yep, minus 3. Check it out real quick, make sure your rule works for one of those other points, and then move it on. So let's move it on. That's the basic as translations. Let's do a reflection now. All right, the last topic that we were working on, we're making sure you knew how to graph a horizontal vertical line, as now we do reflections that are all based off of that. So let's start off with that first one there, number 10, a reflection across the x-axis. So reflected over across the x-axis, first thing I would do is highlight it. Make sure you know where your x-axis is at. Okay, my x-axis we know is, well, right here. I want to reflect this over that line. So imagine if you could take your paper right there and fold it on the x-axis, and what's going to happen to that triangle? It's going to kind of come up, right? So if you could, you know, you've done arts and crafts in years prior, all right? If you fold along that line of reflection, you get that flipped image on the other side, right? So do that. So I pick a point and just start following it. V is how far away from the line of reflection? 1 unit. So when I reflect it over, it's that same distance. We call that equidistance. So 1 unit away, V prime is right here at 1 unit away. And then U prime, 1, 2, 1, 2. And then W prime, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Why would U prime be way up there?
U prime, 1, 2, 1, I can't count. That'd be why. Thank you. So 1, 2, 1, 2. There you go. And as I would have eventually drawn out the picture, hopefully I would have realized that they were not congruent. Reflection is isometry, so it should be congruent. So now that you draw that over, if you fold it, like I said, back on that line of reflection, it should match up exactly. Okay. The only thing is, I always have students that don't correctly do the right line of reflection.
I thought reflect is like you would be on this. Oh, but I don't know.
Okay, so let's go on the next one. Go reflect over the y-axis. So y-axis, highlight that y-axis, your line of reflection. Okay, it's going right here. Now as you reflect that thing over, now we're kind of going more what? Left, right, right, left on that regard. So if you could fold it like that. Okay, I is how far away? And so I prime is on the other side at 1 away. H prime is how far from your line of reflection? 1, 2, 1, 2. Now J is on the left side, so that's going to find itself on the other side, right? The right side. So how far is J away? 1, 2, 3, 1, 2, 3. And like I said a few minutes ago, with transformations, some of them can get kind of messy, just meaning they lie on top of one another. So that's where that notation style of using those primes come into play. Make sure you have those primes on there. X-axis, y-axis usually fine. It's the next group. Okay, when I say reflect over line x equals -1, go draw on that line of reflection. So when you're drawing that line of reflection now, what type of line is that going to look like? Is it creating a vertical line or a horizontal line? It's a vertical line. Okay? When we say x equals -1, it's going to create a vertical line. X equals, it goes through the x-axis right here at -1. So that is your line of reflection. You want every point that has an x-coordinate of -1. And when you start listing those off, -1, 5, -1, 10, -1, 0, -1, -2, it creates that vertical line. Once you've done that, there's nothing different now. Okay? How far away is G? 1, so on the other side it's going to be 1. So G prime puts me here. F is how far? 1, 2, 3. 1, 2, 3. E is what? 1, 2, 3. 1, 2, 3. And what's going to happen to H prime?
It's supposed to stay where it's at.
Yeah, H is on the line of reflection. So because H is on the line of reflection, H prime will be as well, because it's like 0 away. Draw it out, take a step back.
So that H will be E.
Oh, thank you. And when you draw it out then, all right, we got ourselves, I said it again, didn't I? You said E, I did the H. We should have that same shape. Okay, how about 13 then? Reflect over line, y equals -1. So you gotta know again, is that horizontal or vertical? That's the biggest issue I see. It's about 75% of you usually always okay, but there's about a quarter of you that usually mess that up. So y equals -1 is going to be a horizontal line right there. So now we're gonna reflect that thing going up, right? So take it, reflect it up. M is how far? 1, 2, 3, 1, 2, 3. 1, 2, 3. N 1, 2, 3, 4. 1, 2, 3, 4. And K right above M. Take a step back. Should be the same picture, except reflected over. Okay. So that's crazy right now. Reflections are getting. Okay. Now eventually we'll get into some where it's not nice horizontal vertical line. We ain't there right now. We're just doing the basics. Okay. All right. So let's look at the next part. And what is the next part? Bless you. Next part is tell me then the rule. Okay. So on the other side, when we just wrote that, I want you to tell me you're reflecting it over the line. X equals 5, y equals 3, the x-axis. Tell me what the rule is that gets you that. So when you look at number 14, somebody, what is that rule? Reflection over the x-axis. And that's what I'm looking for an answer there. Okay? That's it. Don't overthink this. 15. What's my line of reflection on there?
Reflection over the x-axis equals 1.
Yep. So
-1.
x equals -1. Draw on that line of reflection if you need to. Draw your attention to it. Anytime it's vertical like that, it's x equals something. And in this case, as you said, it is the reflection over x equals -1. That's all I need from you guys. Okay. All right, so let's take a look at that. All right, let's do some rotations. In order to do rotations, I'm going to give you some patty paper. It takes 10 times easier than it used to. So with the patty paper here, in a second, pass it on to me. Give you full sheets here, all of that. We'll do construction of the last rotation, which is rotation. Okay, the ones that you see on your paper there, these are all 90-degree rotations. Eventually we'll get into some that are not 90-degree rotations, and those are just pain in the ass. There's no way to say it. They're just a pain. We'll do those in a few weeks' time, a couple weeks I guess, but not today. We're going to do the nice easy ones to kind of start off with. And then we'll talk it back to how do you do rotation when it's 25 degree or 6 degree. That brings in our protractor and our compass on that. Okay, so let's talk about how we do a rotation here. And I'll do my best to kind of describe this up here. Let's see if I can freak out this board. Okay, so you have to have a point that you need to rotate about. Typically right now, to start off with, the point of rotation is going to be around the origin. So on that patty paper that you just got, what I'd like you to do then is, obviously take it, and you're going to transfer over two things onto that patty paper. First thing is, don't move it once you get it on there. Let's see if this board's going to freak out or not. Okay, first thing I want you to do here is, it's starting to freak out. Okay, is where the origin is on that. Take the origin, put a point there, and draw just a mini XY axis. Just a mini XY axis. Okay, so on your patty paper, right where you put that on there, you want to draw the origin on there, which is a mini XY axis. That's going to allow you to then rotate that paper and keep track of how many degrees you've rotated it. So 90, 180, another 90, okay? And then the other thing is, go ahead and trace over your pre-image onto that paper. So on your patty paper, you should have two things on there. That mini XY axis, as I freak out the board again, and then draw over the pre-image. And as you draw over that pre-image, include your vertices as well. So that when you rotate this thing, you'll know where does E prime land at, where does G prime land at, okay? So I'll give you a second to transfer that over. And on your patty paper, you should have two things on there. That origin, that point of rotation, so that you can keep track of things, and then your actual pre-image for us to rotate it. I'll give you a second. If you're not sure what I was describing, this is your chance to ask it out. Ask somebody, ask me. Once we do like 1 or 2 of these, it's pretty quick. Okay, so yep, that's all I need. Okay, it's on the studio. So again, as I was saying, they're the same. It's got mini XY origin to help keep track of rotations, along with this pre-image. That's the only thing you want on that patty paper. All right. Now, rotating. First thing is you gotta know what direction to go. The directions, if they don't tell you, okay, my default is always to go counterclockwise. That is the default if they don't tell you which way to rotate. Now, as I look at my directions here on 16 and 17, they do. They specifically tell you to go counterclockwise. This one will do the other rotation of clockwise. All right. Next thing is you got to know which direction is what. Okay. So if you're not sure which way clockwise is, well, you all got phones. Look at them. Well, that doesn't work because there's no watch on there that does that. So look at my clock. Okay. You guys are all digital. Let's go look at an analog clock. Okay. If you want an analog clock, all right, this is clockwise. So if you want to go counterclockwise, you want to go, well, counter to that. You want to go the other direction. All right. So now what we're going to do is take our patty paper. You've moved out around your patty paper, line it all back up again. You got that mini XY axis right back there at the origin. Your pre-image is right back on top of your piece of paper. Now make sure you know which direction to turn that paper. If I start turning my paper that way, is that the correct direction there? Nope, that's clockwise. So on mine, what are we going to do? 90 degrees counterclockwise. So how many turns of the paper do I need to do? 1 turn. This is 4 quadrants, right? 4 quadrants, each quadrant is 90 degrees, right? So I'm keeping track of that origin and that turn, and 1 turn of the paper does this for me, okay? It lands that quadrilateral just like this, okay? So it should be, as I really freaked out the board here, okay? Let's see if I can transfer that over easy enough, okay? Whoops. All right, so as I transfer that over, I didn't get everything transferred over, so somebody's going to kind of help me out here. Where does that G prime land at, somebody? What, comma what? 3, comma what?
2.
3, 3, 1 I'm hearing more of, okay? So 3, 1, that should make sense. There is a pattern that happens with that. Okay, and then where's F prime landing at? 1 negative what? 2. Okay, E prime, that's at what? 2 negative 3. And then lastly, D prime is at where? 4 comma negative 2. So I'll finally put those on there. And G prime. And after you get that copied over, take a step back and then check to see if, you know, that does look pretty darn similar. So on you guys, it's easier with my board right here. I'm keeping my paper, and I'm just kind of sliding my pencil underneath that paper to put those in the correct locations, okay? It's all about having that kind of point of rotation as reference on your patty paper. That's the key to know how many turns you've done and then to line it up nicely with things. All right, take 17 if you haven't done so yet. Use that patty paper again. On that patty paper, put a mini XY axis there, start fresh, trace over the pre-image, and once that's all traced over there, do that rotation, okay? Make sure you know which direction to go. Read the directions carefully. If it doesn't tell you which direction to go, the default is always to go counterclockwise. Okay? Counterclockwise is my default. But it does tell you on 17 to go clockwise. And again, this is now your time to ask. Rotations are a bit of a pain to try to do on here, so this is your time to ask. I'll come around and help you. Okay? That's about as crazy as rotations at the moment are going to get. Rotations later on do get crappy. It's the worst one, but we're not there yet. Stay there tomorrow. Okay? Sometime maybe next week. Okay? Yeah, that looks right there. So you get that on there, and which way is clockwise? There's one turn. And there you go. Put it on there. And I would just put the pencil underneath that patty paper just to copy it on over. Okay? All right. So with time here, that's where we'll kind of pause here for us. We'll pick these up. I think, is there a backside to that? Yep. So a 270, and then we'll do one knot on there. We'll lead off that tomorrow as a warm up. Okay. But you got the basics there of transformations. Those three are in some. And then if you need more padding paper, you guys know where it's at, and you use it randomly throughout this next topic. Okay. So if you need more, feel free to grab it. Okay? Tomorrow we'll come in, like I said, we'll go over any questions and do that last bit there. And then we'll get into the next part. We'll be back in our book, so please make sure you do bring your book tomorrow. Okay? And when I tell you need the compass and protractor again, it's not for a little bit, but you will need those back again. Okay? Yeah, that's you. Substitute your notes, whatever you want to do. If you need more, with